Good morning, everybody. It's April 1st. This is Calculus 1, 5.7 rectilinear motion with integrals this time. So a different chapter. I strongly suggest that you read pages from the actual textbook, 376 through 382. If you're using the online version of the textbook, I would imagine that these numbers are going to be a little bit higher, but you'll see these pages. Find 5.7 and to give it a read. The relationships. Remember the relationship when we were dealing with derivatives, the first equation that we were given typically was the position function. And you take the first derivative of the position to get the velocity function. Remember, there's a lot of different notations for this. We could either call this S prime, or we could call it the derivative of S with respect to time. If you take the derivative of the velocity machine or the second derivative of the position machine, you're going to get acceleration. A couple of different ways to write that. We could take the second derivative of the position function with respect to time twice, or we could take the derivative of the velocity machine with respect to time. So taking the derivative starting with the position and going all the way down to acceleration is what we did in chapter 4. In chapter 5, now that we know how to take the antiderivative of different functions, we're going to start with the acceleration and build up, work our way backwards all the way to the position function. So we're going to take the antiderivatives. The new stuff is start with the acceleration. One antiderivative away from the acceleration is the velocity. What do you think one antiderivative of the velocity is going to be? That's right. The position is one antiderivative away from the velocity. So if you remember from taking the integrals, then we had some initial value problems. That's going to be important because when we take the antiderivative of something, we get plus c. The plus c on the velocity will be the initial velocity. We're going to call that v sub 0. The plus c on the velocity function, we'll call that like c1, is going to be the initial position. This will make a lot more sense when we start doing some sample problems. A couple of problems in the section 4.6 said, how do you find distance? Find the net distance traveled and the total distance traveled. We've got a new way to do that. Pause the video, think if you can figure out how we're going to do that. All right, welcome back here. The net distance, now called displacement. So anytime they use the word displacement, they're really talking about the net distance. So the distance from where you started from to where you ended up is the definite integral of the velocity function. So it's the area under the velocity curve from one time value to the second. Velocity, remember, is the derivative of the position. So it's the area under the velocity curve from one t value to the next. This is the fundamental theorem of calculus, where you take the antiderivative of s to get s, and then minus the original position, the c's will cancel out, and you're left with net distance. Again, we're going to call net distance displacement. Displacement is the difference from where you ended up and where you started from. Okay, this is going to be a little bit more difficult. Let's try to find the total distance traveled. Anytime the book just says the word distance, it implies that they want the total distance traveled. Otherwise, they would use the word displacement for the net distance, okay? So total distance traveled TDT is just distance now. Pause the video and see if you can figure out what function we're going to use to find the total distance traveled. All right, welcome back. The total distance traveled, it's the area under the absolute value. So if we have some kind of a function that dips down below the t-axis, we know that the area from here to here is going to result in negative distance traveled. And the area from here to here is going to be positive distance traveled. Remember, this is a velocity versus time curve. When we're running displacement, we keep known negative area negative, and we keep positive area positive, and the displacement might be negative. You might be to the left of your starting point. With total distance traveled, we need a way for all this negative velocity or distance traveled to the left. We need a way to negate that known negative distance traveled and add it to the other positive distance traveled. The way to negate negatives is with absolute values. I hope that makes sense, guys. In our sample problems, we'll do a sample from every homework set, but I'm going to put those in additional videos here so that you don't have to watch a 20-minute video. You can watch 4 or 5-minute ones. The homework, you might be ready to try it. Page 383, 5 through 13 odds, and number 14. Remember, all the odds answers are in the back of the book, but use the resources, the solutions to the odds and evens posted on the assignments page, thanks to Wiley Publishing Company. I hope you have a great day. Stay healthy, everyone. Talk to you soon.